Good morning, students. I am Professor Priya Sharma, PC Department, SIRT College, Bhopal. Sage Anandam. So, this is our 12th lecture of the lecture series Digital Circuit System subject, which we are going through. 12th lecture will cover the multivibrators. So, basically, what is a multivibrator? A multivibrator is an electronic circuit that is used to implement two stable systems like oscillators, timers, and flip flops. It is characterized by two amplifying devices like transistors or other devices, cross coupled by resistors or capacitors. Classification of multivibrators includes there are three types of multivibrator circuits depending on the circuit operation. First is the astable multivibrator in which neither of the state is stable. Second is the monostable multivibrator in which one of the state is stable and the other is not stable. Third is the bistable multivibrator. It remains in either of the state indefinitely until it is triggered further. Coming to the astable multivibrator, this is the basic circuit diagram of a stable multivibrator. A multivibrator that generates the square waveform without using external triggering pulse is known as a stable multivibrator. It is also known as free running multivibrator. The a stable multivibrator circuit consists of two transistors, namely Q1 and Q2, a cross-coupled feedback. This is how cross-coupled means the input of one transistor is connected to the output of the another transistor through a capacitor, and the input of this transistor has been connected to the output of another transistor using the capacitor C2. This is cross coupled. A feed two capacitors and four of the resistors. Coming to the operation of the stable multivibrator, first of all, let us consider that the Q1 is on and Q2 is off. VCC will drops across RL1, hence VC1 will be 0. So, point A will be at the ground potential, at this will be whole of the current will go down, so it will be grounded, and the point A will be at the ground potential. Therefore, the path for the flow of VCC will be this. Therefore, VC2 is equals to VCC. As you can see, VC2 will be equal to VCC, and the VB2, the base voltage of this, as it is coupled through the output of first transistor, so it will drop down to a negative terminal, it is grounded. Similarly, considering the second case when Q2 is on and Q1 is off, therefore the V terminal V point will be at the ground terminal, and the whole of the VCC will appear across the VC1. Therefore, C2 will discharge and C1 will start charging. So this is the same thing. VC2 will reach to VCC and then drops suddenly when this will be on, and VB1 will again drop because the output of this will be low, so it will drop to a negative voltage as the VB2 has dropped earlier, so it will start rising and will be in a stable state. And VC1 will has dropped down when it was on, and now it has reached the position of VCC when Q2 is on. So this is the summarized form of the timing diagrams. This is how we have taken the timing diagram. Drawing of a timing diagram in these questions is very important. Circuit diagram and timing diagrams has to be drawn whenever multivibrators are being asked in the papers. Coming to the frequency of oscillations, how it is calculated, it can be proved that off time for Q1 is T1 is equal to 0.69 R1C2, and that of Q2 time, the frequency of oscillation time T2 is equals to 0.69 R2C1. Hence, the total time will be T1 plus T2, which is 0.69 R1C2 plus R2C1. If we consider that the values of R1 and R2 are equal and is equivalent to R, and similarly the values of C1 and C2 are equal and is equivalent to C, then the total time T will be taken as 1.38 RC. Therefore, as we know, frequency is equals to 1 upon T. So, solving this, we comes out with a equation which equates F equal to 0.7 upon RC. Applications of astable multivibrator includes it is used as a rectangular wave generator, it is used as a square wave generator, it is used in the flasher circuits and in ramp generators. Next, coming to the monostable multivibrators, a monostable multivibrator will have one stable state and one temporary quasi-stable state, and the level of transition depends on the external triggering pulse is known as the monostable multivibrator. As you can see from the circuit diagram that this is the can see from the circuit diagram, a very small changes are there as compared to A-stable multivibrator. The capacitor C2 was used over here in the A-stable multivibrator, but in monostable it is used over here. So coming to the operation of this, when the circuit is switched on, transistor Q1 will be off and Q2 will be on. Capacitor C1 gets charged during this state. When a positive trigger is applied to the base of the transistor Q1, it turns on, which turns the transistor Q2 off. Capacitor C1 starts discharging through the state. Transistor Q1 remains in the on state due to the positive voltage from the collector of transistor Q2, which is turned off. Transistor Q2 will remain off state until the capacitor C1 discharges completely. When the capacitor C1 discharges completely, transistor Q2 will turn to on, which turns the transistor Q1 off. This is the timing diagram, which is being drawn from the working of the transistors. You can go through. Coming to the applications, it is used as a timer, it is used to gate another circuits, it is used as a delay generator. Then the bistable multivibrator, a multivibrator that has two absolutely stable states that can stay in that in one of two states indefinitely, is known as a bistable multivibrator. It changes its state when it gets triggering pulse and stay in that state until it gets another triggering pulse. Next, again, little changes have created a bistable multivibrator. Like both the capacitors are used at the inputs of the transistors, and resistor positions have also been changed from earlier. The operation has been shown here. When the VCC is applied, one transistor will start conducting slightly more than the other. Let us assume that Q2 is on and Q1 is off. When Q2 is on, the potential at the collector of Q2 decreases, which in turn will decrease the potential at the base of the Q1 due to the potential divider action R1 and R2. The potential at the collector of Q1 increases, which in turn further increases the base to emitter voltage of the base of Q2. The voltage of the collector of Q2 further decreases, which in turn further reduces the voltage at the base of the Q1. This action will continue till Q2 becomes fully saturated and Q1 becomes fully cut off. Thus, the stable state of binary is such that one device remains in cutoff and another device remains in the saturation. It will be in that state until the triggering pulse is applied to it. It has two stable states. For every transition of states, triggering is required. At a time, only one device will be in a conducting mode. The applications of bistable multivibrator includes: it is used as a flip-flop, it is used as a memory cell to store the 1-bit operation, it is used as a basic unit of to build registers and counters. That's all for the multivibrators. Comparison is given with whatever we have studied through all the PPT. It is the tabular form of the multivibrators. That's all for the multivibrators. I hope so it is clear. It is very simple. If the circuit of one has been understood, the rest of them can be made easily. So all the very best students. In case of any query, you can contact me. Work very hard. Thank you. Sej Anandam.